بسم الله الرحمن الرحيم الحمد لله رب العالمين الصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. I would like to welcome my students from grade 12 into their fourth online video, and in this video we will talk about the lesson of combinations. So we'll continue here with the lesson of combinations, and today we will discuss some of the exercises regarding to this lesson. But before we start with the exercises, I would like to remind you, so that we remember together, the properties of combinations that we took in the previous class. So the first property that we took in the previous class was the relationship between combinations and factorial. And in this relationship, we learned that n combination r is actually equals to n factorial over n minus r factorial, n minus r factorial multiplied by r factorial. And we call this the relation between combinations and factorial. So if with close inspection of this relationship, we can notice that this is the same as the permutation, but the only extra thing is that we have r factorial here at the end. So this drives us into the second relationship, or the second property, which is the relationship between combinations and permutations. So in this relationship, we learned that n combination r is actually equals to n permutation r divided by r factorial. So n permutation r is actually this part, which is n factorial over n minus r factorial, and what we have extra in the denominator is that we have r factorial. The second relation here we called the relation between combinations and permutations, and we usually use this relationship whenever we want to evaluate the value of a combination. Okay, the third important property was the reduction property, and in the reduction property we learned that combination nr is the same as combination n and n minus r. And we said that we will use this, and we actually used it in the previous class to reduce the number that we have at r. So we said if this number r is more than half of n, then we usually use the reduction property to reduce the value of r. And we will see this today in examples, inshallah, and we will explain it, or will refer to it on time. Okay, the fourth property was a combination n. So if the two numbers of the combination are the same, we learned that in this case the answer is 1. So combination n was equal to 1, and I encouraged you in the previous class to compare this to the permutation of nn. We said that permutation nn was equal to n factorial. So this is the key difference between combinations and permutations, something that you should notice. In permutations, permutation nn was equal to n factorial, while in combinations, combination nn is equal to 1. The fifth property was combination n0. Well, according to the reduction property, these two should be equal. Combination nn should be equal to the combination n minus n. n minus n is 0. So combination nn and combination n0 are actually the same thing, and they are both equal to 1. So combination n0 is equal to 1 as well, and this serves as the fifth property. You can compare this to the permutation, to the value of permutation n0. and permutation n0 is also equals to 1. So actually, this is something that both combinations and permutations yield into the same answer. They both give you the same answer. Whether it's combination n0 or permutation n0, you'll get 1 either cases. Okay, the sixth property was combination n1. And we learned that this is equal to n. So combination n1 is equal to n. And this is also actually the same as the permutation. So on the other hand here, we can say that n permutation 1 is also equals to n. They are both the same thing. So this is the sixth property now. And the seventh property was what we called the Kerkies relation, which was the following. It was combination nr plus combination n r minus 1 equals to combination. We add 1 to n. Okay, let's investigate this one. Look, if you have two combinations, and these two combinations are added to each other, so what's between them is an addition. If it's the same n, and if r is consecutive, and what we mean with consecutive is that we mean that they're after each other. The difference between them is only 1. Like 6 and 7, like 7 and 6, like 9 and 8, things like that. So if you have two consecutive combinations, two consecutive r's, and you have the same n, and there is an addition between them, then you can replace both of them by one combination only, in which you add 1 to n, so you write n plus 1, and you select the bigger r. So the bigger r in our case is r, this one, so it's going to be r. And we call this a Kerkies relation. So a Kerkies relation serves whenever you have two combinations. These two combinations are added to each other, and what's between them? And they have the same n, and r is consecutive. This was the seventh property. The eighth property was the same case, which is combination nr, but this time if what's between them is division. So if you have two combinations with the same n, and r is consecutive, and what's between them is division. What do you do in this case? You do the following. You write n, which is this number, minus the bigger r. Which one is the bigger r? It's r. Plus 1, and you divide by the bigger r. So it's going to be n minus r plus 1 over r, and this is an important formula, and we will see also this formula in the fourth and last lesson in this chapter, which is about the binomial theorem. We'll see something very close to this one. And the last property was the following. It's if you have two combinations, and these two combinations are equal, and they have the same n, but r here is supposedly r1, and here is r2. So if you have a scenario like this, then you can say either r1 is equal to r2, so they are equal to each other, or you say that r1 plus r2 is equal to n. And this is also an important property that we use a lot to solve combination problems. So if you have two combinations that are equal to each other, if they have the same n and r is said to be different, so it's either r1 and r2 are the same number, so either it's equal to each other, or r1 plus r2 is equal to n. And I think in the last class we have seen some examples regarding that. So in this class today, we will see some questions of permutation, and we will see how do we use these properties to solve those questions. It's crucially important that you memorize these formulas, because we use all of them to solve problems of combinations. Okay, so now let's look at some exercises of combinations. And in this class, we will talk about some some calculation problems of combinations. Inshallah, in the next class, we will talk about some logical problems of combinations and also of permutations. So we will see how we use combinations and permutations in the context of word problems. The questions that we're going to solve today are going to be from page, first of all, from page 92. And I'm going to solve some questions from question 2, and from question 2, we will select A, B, and C. So let's see. The question says the following. This question is asking us to find the value of R. Find the value of R. Okay. And in the first case, A, we are given that combination 28 and R plus 4 is equal to the combination of 28 and R minus 2. And the question is to find the value of R that satisfies this question. So let's see, how do we do this? Okay, first of all, you must analyze what you have. So in this question, you have two combinations, and these two combinations are equal to each other. Do we have a formula that looks like that? Yes, it's actually the ninth formula, or the ninth property from the properties that we wrote. Look, so we have here two combinations, and these two combinations are equal to each other with the same n. And here also we have two combinations, and these combinations are equal to each other with the same n. So it's quite the same scenario. So we can say directly that either R1 and R2 are equal to each other, or R1 plus R2 is equal to n. So let's see, how do we do that? So we can say here that either, look at this directly, either R1, this is R1, and R2, this one, so R1, which is R plus 4, equals to R minus 2. So either they are equal to each other, or the other possibility is that when we add them together, R1, this is R1, plus R2, which is R minus 2, this is R2, is equal to n, and n in our case is 28. So we have two different scenarios, either this one or that one. And we will solve this one, and we will solve that one, and we see how much is the value of R that we get from each one of them. So let's see. In the first one, we have R and number, R and a number. So we put the R together, and we put the numbers together. So we get R, and when we transpose this one, we get R minus R equals -2, and when we transpose this one, we get -4. So R minus R is 0, equals to -2, and -4 is -6. And this is not possible. These are two different numbers, there is no R. We've just subtracted R from R, so we got 0. So there is no R here, and 0 is not equal to -6, so this is a dead end. So we say here that there is no answer. So this scenario gave us no answer. So we might get the value of R from the other scenario. Let's see how. So here, R plus R, we have 2R. 4 minus 2, we have +2, equals to 28. Okay, good. We have 2R plus 2 equals 28. We can take this number with that number. So 2R equals 28 minus 2. So 2R equals to 26. Good. Now we divide both sides by 2. So this is by 2 and the other side as well. So R is equal to 26 divided by 2, which is 13. Okay, so this means that this is 13 plus 4, which is 17. And this is 13 minus 2, which is 11. So it makes sense. So we say that this is the correct answer in this case. And just to check, so this means that the combination of 28 and 13 plus 4, which is 17, equals to the combination of 28 and 13 minus 2, which is 11. And are these two equal? Yes, they are. How are they equal? Because of the reduction formula. You see, 28 minus 17 is equal to 11. So, and we know that now look at this. So we know that combination NR is equal to combination N and N minus R. So this is the same thing. So because of that, R is 13 is the correct answer. It's always useful to check. It's always important, actually, in all of the questions of chapter 2, to check your answers by putting the value that you got in the question and see if it makes sense or not. So let's continue with the same question. This is still question 2. And in question 2, we want to find the value of R. So find the value of R. And this time, we will solve part B. Let's look at that. So part B says the following. We have a combination of 20, the combination of 20 and 2R equals to the combination of 20 and R plus 2. Okay, so here we come into something that is quite similar to the previous question. So it's the same scenario. We have two combinations that are equal to each other, two combinations that are equal to each other, and they have the same R, the same N, sorry, and we want to know how much is the value of R. So we can say directly that it's an either or scenario. So it's either or. So it's either 2R, this is R1, equals R2, this is R2, which is R plus 2. So it's either this scenario, or 2R plus, which is R1, plus R plus 2, which is R2, is equal to N. And N is how much? N is 20. And now we will solve each one of these scenarios and see what answers do we get out of each one of them. So in this one, we will transpose this R to the other side. So we transpose this R to the other side. So it becomes like 2R minus R equals 2. 2R minus R means R equals 2. Okay, so this is the first possible answer. R is equal to 2. Let's substitute and make sure. So to check, look, that we have combination 20 and 2 times 2 because R is 2. So 2 times 2 is 4 equals combination 20. And 2 plus 2 is 4. Of course, these are equal. They're exactly the same thing. So they must be equal. So this is the first answer. R is equal to 2. The second answer, 2R plus R is 3R. So 3R plus 2 is equal to 20. Let's transpose the 2 to the other side. So 3R is equal to 20 minus 2. So 3R is equal to 18. We divide by 3 both sides. So this is canceling 3 from both sides. So R is equal to 18 divided by 3, which is 6. So this is the second possible answer, which is 6. And to check our answer, we'll put 6 here. So 2 times 6, this is going to be 12. So combination 20, 12 equals combination of 20 and 6 plus 2 is 8. Are these two equal? Yes, they are. Why? Because 20 minus 12 is equal to 8. And this is the same according to, so these two are the same in accordance to the reduction formula. So we found the value of R, and this time we have two values of R. So R is equal to two values, either 2 or 6. It's two possible answers. So it's possible in these questions to get one answer, like the previous one. And it's also possible to get two different answers, like this one. So do not limit yourself to one answer only. Sometimes you can get two answers, and sometimes getting one answer is the right thing. Let's see the third one. So here, question 2, which is the same thing. Here we want to find the value of R. Find the value of R. And this question, C, says that n permutation R is equal to 120 n combination n minus R. Okay. Well, now this question has more than one way to do it. And let's see how. Okay. One method to solve this question, or first of all, the first problem that we might see in this question is that we have a permutation on one side and a combination on the other side. So in this case, we might put them back to reference of the same thing. We know that there's a relationship between permutation and factorial. And there is also a relationship between combinations and factorial. So we can put this back or write this back as a factorial, and we write this back as a factorial, and then we solve as a factorial problem. This is one way to do it. Let's see. So this is one method, or method one. I'll show you later another method with which we can solve the same problem, and we get the same answer. Let's see. So the first method, I'm going to change this into a factorial, and then change this also into a factorial. Okay, so we need to know what is the relationship between a permutation and a factorial. In this paper, I wrote the relationship between the combinations and factorial. But it's worth noting that n permutation R is equal to n factorial over n minus R factorial. And we took this in a previous lesson. So I showed you the relationship between the permutation and the factorial. This is the relationship between the permutation and the factorial. And notice that it's actually the same as this relation, but we have an R factorial extra here. Okay, so let's do this. Okay, so in this method, I am going to change this into a factorial. So I'm going to write, instead of n permutation R, I will write it's n factorial over n minus R factorial. N minus R factorial equals to 120. Okay, now look at this, guys. 120 is 5 factorial. And since I want to change everything into factorials, it's also wise to say that 120 is also a 5 factorial. So I'm changing basically everything into factorials. So 120 is 5 factorial multiplied by combination n and n minus R. So what do we do here? Look, we know that we have a formula for combination nr. nr, we say it's n factorial over n minus R factorial multiplied by R factorial. Well, you can think of this, in our case here, you can think of this, all of it, as this is R. So to evaluate this as a factorial, you say the following. You say it's n factorial, so you write here n factorial, which is this one, over n minus R. This is R, all of it. So n minus R, minus both of these. So it's going to be minus n plus R. Why is this plus? Because the minus, when you say n minus R, the minus is for both of them. The minus for the n is minus n, and the minus for the minus R is positive R. So it is n minus R. All of this is R. So this is n minus both of them, minus n plus R. Over, times, R factorial. R is this. So R is n minus R factorial. So I'm applying the rule also here. So it is n factorial, the one on top, over n minus R. Remember that this is R, all of it. So n minus both of them. So n minus both of them. Times R factorial. And remember that all of this is R. So times R factorial, which is n minus R factorial. It's quite basically the same as the formula. It's the one on top factorial over the one on top minus the one in the bottom times the one in the bottom factorial. Okay, hope this is clear. So let's see. So in this side now, we can do some simplification. You see, n minus n becomes 0. So what we get is n factorial over n minus r factorial equals 5 factorial multiplied by n factorial over r factorial in the denominator multiplied by n minus r factorial. So n minus r factorial is right here. R factorial is this one, n factorial, and the same thing on the other side. Now it's really important that you understand something. Look at this, guys. We know that if you have a, let's put this as a side note, a over b multiplied by c over a. In this case, I can cancel this a with this a, one from the numerator and the other one from the denominator, and we will get c over b. C over b. So canceling is always possible in multiplication as long as we cancel one from the numerator and one from the denominator. We also can cancel in a different scenario. When you have something like this, in this scenario, when there is an equal between them, not a multiplication, but an equal, you can cancel something from the numerator with something from the numerator. Or you can do something else, which is you can cancel something from the denominator. Let's say that here, for example, we have d over bc. We can cancel something from the denominator with something from the denominator. With equality, with equal sign, we can cancel from the same side, which is either the numerator with the numerator or the denominator with the denominator. Saying this now, I'm saying this now because I want to draw your attention that we can cancel n factorial with n factorial, because there is an equal between them and there is multiplication here. So it's one term, we can cancel. And the same thing, we can cancel n minus r factorial with n minus r factorial. And please pay attention to this property because we'll use it a lot. Canceling the same side from both sides of the equation. So if you have an equal sign, you can cancel the numerator with the numerator or the denominator with the denominator. We do this a lot. So here in this side, we end up with 1. So 1 equals, in this side we end up with 5 factorial divided by, in the denominator we have r factorial. Okay, what can we do next? We can cross multiply for sure. So r factorial equals 5 factorial. If 2 factorials are equal, you can simply ignore the factorial. So in this case, we can say that r is equal to 5. So this is the answer that we're looking for, which is r is equal to 5. Now, if you want to check, here, let's check. So if you want to check, you put r by 5, so you get n permutation 5 equals 120 multiplied by combination n and n minus 5. How do we check this one? It might be not possible at the beginning to check it because we have n here, but I'll show you after I explain method 2 how can we carry on with this check and see how do we evaluate it and actually check our answer. So this is method 1. I'm going to stop with the check a little bit now. I'll show you method 2 first, and then after that, I am going to show you the check. Okay, so method 2. If you solve with this method, it's fine. If you solve with the second method, it's also fine. This second method needs you to be a little bit more alert than the first method, and I'll show you why. Now, in the question, we have n permutation r is equal to 120 multiplied by n combination n minus r. Okay, so this one actually, this one right here, it's quite familiar. And why is it familiar? Because we have it in a formula. It's right here. N combination n minus r. N combination n minus r. According to the reduction formula, this is the same as nr. So n minus r is the same as n minus r is the same as n combination r. So I'm going to replace it. I am going to replace this by n combination r. That's the first thing it will do. So I'm going to replace this one according to the reduction formula to nr, right? The second thing I will do. Now combination nr has a relationship with the permutation nr. You see, according to the second formula, nr combination is the same as nr permutation divided by r factorial. So I can do the same thing here. I can say that n permutation r equals, this is 5 factorial multiplied by, here, this is n permutation r divided by r factorial. Okay, now what can happen? We can cancel the whole thing here with the whole thing here because they're the same. We get 1 and 1 in both sides. So we end up with something similar to what we have ended up here with. We get 1 in this side equals to 5 factorial divided by r factorial. We'll cross multiply, so r factorial equals 5 factorial. We'll get rid of the factorial from both sides, so r is equal to 5. We end up with the same answer. So here I used the relationship between permutation and combination with factorials. Here I used the relationship between combination and permutation. So using this relationship, I have discovered that r is equal to 5. And to check now, if we need to check, what do we do? Now, according to what we said here, this is n permutation 5 is equal to 120 multiplied by, this is n combination 5. Because n minus 5 is the same as 5. This is the reduction formula. And if you, and this is what? This is 5 factorial. So n permutation 5 equals 5 factorial multiplied by, this is n permutation 5 over 5 factorial. The combination is actually a permutation over factorial. Cancel this with this and you will get the same side. N permutation 5 equals n permutation 5, so it is checked. So our answer is correct. Okay, so in the ministry test, you might have a question like this, and then they will tell you that the value of r, and they give you choices, and they give you 5 as one of the choices. So these questions are possible to be in the ministry test. It's not like they're unlikely. And my advice to you is to try to concentrate on the second method, because when you have a multiple choice question, what you need is the fastest way, the shortest way possible to the correct answer. And this is the shortest way. This way is a lot shorter than this way. And it's likely that you don't make a lot of mistakes here. So my point is concentrate on the methods that are short and they get you to the right answer. Always think carefully before you attempt to answer any question. So this is question 2 from page 92. And we will also solve some questions from the same page. So today we'll also solve some part of question 3. So as I told you before, in this class, we will also discuss some numerical problems with numbers. In the second class, we will talk about some logical problems of both combinations and permutation. Okay, this is question 3 in page 92. And in this question, they're asking this time to find the value of n. Find the value of n. So in the previous question, they only asked to find the value of r. In the previous question, we did not have to find the value of n. This time, they're only asking to find the value of n. And I will actually leave part A for you as homework, some home practice. And I will start by solving part B. So part B says 5 in combination 6 is equal to 12 in combination 4. Please make sure that you do the homework exercises. Send them to me so that I can give you the proper feedback. We know if you get them or not. I will not know if you get them or not if you don't send them back to me. So try your best to do the homework exercises and send them to me via WhatsApp, and I will make sure to check them on time. So let's see. In this one, we have two combinations that are equal to each other, n, but we have some coefficients here, 5 and 12. Oh, we cannot apply that formula. We cannot apply the ninth property of permutations. So this one cannot be applied so far. Why? Because this one needs combinations only, with no numbers before the combinations. So we cannot have numbers here or there. So we can't have coefficients. But this time we have some coefficients. We have 5 and 12. So what are we going to do? We will actually try to evaluate each combination since we have numbers here. Let's show you how. So 5 multiplied by, here, this is n permutation 6 over 6 factorial. So I used the property of the relationship between combination and permutation. So n combination 6 is actually n permutation 6 over 6 factorial, equals to 12 times, this one is n permutation 4 over 4 factorial. Okay, good. Now what do we do next? This permutation means that we have 6 actions and n is the largest one. I hope that you still remember this from the lesson of permutation. What do we mean by that? I mean I need 6 actions, and from these 6 actions, and from these 6 actions, n is the largest one. So we have n, and then we have n minus 1, and then n minus 2, and then n minus 3, and then n minus 4, and then n minus 5. How many actions are these? The 6 actions. 1, 2, 3, 4, 5, 6. 6 numbers. Divided by 6 factorial. 6 factorial is 6 times 5 times 4 times 3 times, okay, we can say times 4 factorial. And why did I say it's times 4 factorial? It's for a reason that you will see in seconds. Equals to, we have here 12. So it's 12 multiplied by, okay. This time we have 4 actions starting with n. So it's n minus 1, this is the second action, n minus 2, the third action, n minus 3, the fourth action. So n minus 1, n minus 2, n minus 3. These are 4 actions. Over, I don't have to write 4 times 3 times 2 times 1. I'll write 4 factorial. And why do I do that now? Because as we said in the previous example, we can always cancel things from the numerator with things from the numerator, and things from the denominator with things from the denominator, as long as it's one term here and one term here. And all of this is one term, by the way. It's multiplication. And all of this is one term. So can I cancel? Yes. What do I cancel? Cancel n with n. n minus 1 with n minus 1. n minus 2 with n minus 2. n minus 3 with n minus 3. So here we have only 1. Cancel 4 factorial with 4 factorial. They're both equal. Cancel them. Okay. Can we cancel anything more? Can we cancel the 6 with the 12? No, we can't. Because the 6 is in the denominator and the 12 is in the numerator, and what's between them is an equal sign. When you have an equal sign, it needs to be in the denominator both or the numerator both. We can cancel the 5 with the 5, however. Why? Because it's multiplication here. And in multiplication, we cancel something from the numerator with something from the denominator. So what do we end up with? We end up with the following. We end up with n minus 4 multiplied by n minus 5, only these two, divided by, in the denominator, we only have 6. So divided by 6 equals to, in this side, we only have 12. Okay, what do we do now? Now, we cross multiply. So we'll cross multiply this one and this one. So we get n minus 4 times n minus 5 equals 12 times 6, which is 72. Okay, now, how do we solve this? Well, here actually we have two different ways to do it. There is the donkey work, and there is the smart way. And let's start with the donkey's work. So with the donkey's work, what do? We all open the brackets. So n times n squared. N times minus 5, minus 5n. Minus 4 times n, minus 4n. Minus times minus is plus, 4 times 5 is 20, equals 72. This is a quadratic equation, so we need to make it equal to 0. So n squared minus 9n, since it's minus 5 and minus 4n, plus 20 minus 72 equal to 0. So it's n squared minus 9n minus 52 is equal to 0. Now what do? We expand two brackets. We need two numbers. If you multiply them 52, if you minus them 9, this is actually 13 times 4. 13 times 4, if you multiply them 52, if you minus them 9. So it's n and n, 13 and 4. The signs minus. Minus times minus is plus, equal to 0. So either n is equal to 13 or n is equal to minus 4. This one is rejected because it's negative and we can't have n as negative. So n is equal to 13 is the accepted answer. Okay, that's one way to do it. The other way, which I like to call the smart way, because it's shorter. I like shorter methods because shorter methods mean that you will spend less time solving the question in the exam, so you have plenty of time to revise your answers. So the smart way is to know the following. Notice the following. These two brackets are consecutive. They're after each other. They're two actions after each other. So it's a permutation of two actions. And the largest of the two actions, the larger one, is n minus 4. So this side is actually n minus 4 permutation 2. Because it's two actions, and the larger one is n minus 4. Equals 72 is 9 times 8. 9 times 8 is 72. And why did I choose 9 times 8? Because they're consecutive after each other. So there are two actions after each other, and the larger one is 9. So we can say that n minus 4 permutation 2 equals 9 permutation 2. Now this means, therefore, n minus 4 is equal to 9. So we transpose this to the other side. So n is equal to 9 plus 4. And n in this case is equal to 13. So we notice that we get the same answer. But this time we got only the accepted answer and we did not get the rejected answer. And we got it using a shorter way. We did not have to solve a quadratic equation. We just used permutation. I think I've showed you this before in a previous lesson where we used the smart way to solve such problems in which you have 2 factors or 3 factors or 4 factors after each other. They have to be consecutive. If they're consecutive, you can do this. So I hope you understand this one, and we will do one more before we end this class. So let's see. Let's solve one more example. It's from the same page, page 92, question 3. And this time, so still question 3, which is to find the value of n. And we'll see. It's part C, actually. And in this question, we have 2 n combination 4 equals to 35 n over 2 combination 3. Okay. It might seem a little bit intimidating at the beginning, especially with the fraction here, but it's not that hard. Let's check it out. So let's see. So let's do the same strategy we did before. So this one is 2 n permutation 4. I'll change it to permutation over 4 factorial equals 35 n over 2 permutation 3 over 3 factorial. This is what I did before in the previous question. I changed every combination into a permutation. Good. The second step. This is 2 times. These are 4 actions, and the largest is n. So n minus 1, this is the second action, n minus 2, the third action, n minus 3, the fourth action, over, this is 4 factorial, which is 4 times 3 factorial. I will stop at 3 factorial because there is another 3 factorial. On the other side, I'll cancel them together. So it's equal to 35 here. These are 3 actions, and the largest is n over 2. So how do we do that? It's easy. N over 2, then n over 2 minus 1, then n over 2 minus 2. These are 3 actions, and the largest one is n over 2, minus 1, minus 2. Same thing here. So over 3 factorial. Okay. Let's start canceling if we can. Of course, we can cancel some things now. I can cancel 3 factorial with 3 factorial. Always try to cancel once you see some canceling because this makes the question easier. Cancel the 2 with the 4, you'll get here 2. Okay. So let's see. So in this side, I have n minus 1, n minus 2, n minus 3, all of them divided by 2. This 2 equals to, in the other side, there is no denominator now, so it's 35 multiplied by n over 2 multiplied by, okay. Look at this, guys. For this one, I am going to attempt to unify the denominators. So it's n over 2 minus 1. I'll just multiply here by 2 and here by 2. I'll unify the denominators here. So I will get n minus 2 over 2 by unifying the denominators. The same thing here. This is 2 over 1. I'll multiply by 2 to unify the denominators. So I will get n minus 4 over 2. Okay, why do we do that? Now we can cancel. What can we cancel exactly? I can cancel n. Remember, this is one term and this is one term, so I can cancel n with n. I can cancel 2 with 2. I can cancel n minus 2 with n minus 2. I'll be left with 1. There is no n minus 4 to cancel. So let's see, what do we still have? In this side, we still have n minus 1 times n minus 3. In the other side, we have 35 multiplied by n minus 4 over 4. Okay? All right. Now, how do we solve this? We cannot change this into a permutation. So I need to open the brackets. So let's open the brackets. So n times n squared, minus n times 3 is 3n, minus 1 times n is minus n, and minus 1 times minus 3 is plus 3, equals. Also open the bracket here. 35 times n is 35n, minus 35 times 4 is 140, divided by 4. What do we do next? Cross multiply. So 4n squared minus 12n minus 4n plus 12 equals 35n minus 140. Collect these two together, and since it's quadratic, you need to transpose these two to the other side. So 4n squared minus 16n plus 12 minus 35n plus 140 equals to 0. Simplify it into a quadratic equation. So 4n squared minus 16n and minus 35n is minus 51n, plus 12 and plus 140 is plus 152 is equal to 0. You can solve this using ABC quadratic formula. You can solve it using non-simple trinomial. Let's try non-simple trinomial. 4 times 152. 4 times is 608. So I need two numbers if I multiply them 608 and if I add them 51. This is quite challenging, especially that this number is quite big. We will start with this fact. If we add them as 51, I can try 20 and 21. And 31. If I add them, I will get 51. So let's multiply them and see, do we get 608 or not? So 1 times 0 is 0. 1 times 2 is 2. And then 0. 3 times 0 is 0. 3 times 2 is 6. We get 620. We're very close. We want 608. So let's make this 21 and 30. If we add them, we get 51. So 21 and 30. 0 times 1 is 0. 0 times 2 is 0. And then 0. 3 times 1 is 3. And 3 times 2 is 6. We get 0, 3, 6. We got further away. So what do? We will put 19 and 32. If we add them, we get 51. So 2 times 9 is 18. 2 times 1 is 2 plus 1, 3. Put 0. 3 times 9 is 27. And 3 times 1 is 3 plus 2, 5. Now add them. This is 8. 3 plus 7 is 10. And 1 plus 5 is 6. 5 is 6. So it's 608. So these are the two numbers we're looking for. So what do we write? We write, this is non-simple trinomial, remember? So we have to write 4n, extra 4. The sign's minus times plus is minus. And the two numbers are 32 first, bigger number, and then 19. Where do we take the extra 4 from? It's from here, common factor. So we take 4 as a common factor. What do we still have? We are going to have n minus 8 and 4n minus 19 equal to 0. We will cancel the extra 4. So either n is equal to 8, which is good, or n is equal to 19 over 4, which is rejected. And why is this rejected? Simply because it's a fraction. Okay, one might ask me, okay, then this one is a fraction as well. It's not a fraction. If you put n as 8 here in the question, 8 over 2 becomes 4, so n does not become a fraction. Becomes combination 4, 3, which is quite good. If you want to check, you need to put 8 here and here. I'm going to leave that for you. And with this, I'm going to leave you today. Please try to solve question 3a in page 92. This is going to be your homework. And I will try my best to, in the next class, we're going to discuss some of the logical problems of combinations and permutations. We will see how do we see these questions in word problems. And this is going to be the end of permutation and combination. After that, we will start with the last lesson of this chapter, which is the binomial theorem. I wish you all the best, and I wish that your studies are good. I'll see you, inshallah, in the next video.